Our thirst for fossil fuels is driving oil exploration to the harshest corners of the planet. With the latest generation of offshore rig, no reserves of oil or gas are beyond reach. This is the most extreme drilling rig in the world, the Eric Roud. It can drill for oil in the deepest water and the roughest weather on the 7 seas. As we burn our way through more of the Earth's fossil fuels, exploration for oil and gas has moved from land to sea. The oil industry has developed massive drilling platforms, oil rigs, to stand on the ocean floor and drill beneath the seabed. Until now, offshore rigs have been restricted to shallow water, limited by the length of their legs. But the new generation of rigs don't stand on the seabed, they float. The latest and greatest of these floating rigs is the Eric Roud, capable of drilling not just in deep water, but in ultra-deep water. The Eric Roud is named after Eric the Red, a fearless Norwegian explorer who braved the storms of the North Atlantic to discover Iceland. In a few days, this mechanical explorer will begin its first voyage of discovery. Its mission? To search for oil where no one has dared search before. Eric is a self-contained floating city, connected to the outside world only by boat and helicopter. Everything on board is designed around the massive drill at the center, the derrick. Every inch of deck space is crammed with thousands of feet of drill pipe. The crew will live, work, eat, and sleep on board. The accommodation block is at the front of the rig, as far as possible from the dangers of drilling. It contains offices, cabins, the bridge, canteen, and Eric's own hospital. Eric will search for oil and gas in the deep, rough seas off the east coast of Canada, where massive reserves have, so far, been beyond reach. Most offshore rigs can only drill in water up to about 4,000 feet. But Eric can work in ultra-deep water, up to 10,000 feet. At this depth, the rig can't be fixed to the ocean floor. Instead, it floats on 2 massive submerged pontoons. This semi-submersible design is more stable in rough weather, and a system of 6 giant thrusters hold the rig in position while drilling. From the seabed, Eric can drill 20,000 feet through the earth. That's almost 6 miles beneath the surface of the ocean. This is a huge gamble for the oil company in Canada. It costs them $250,000 US a day to lease the Eric Roud from its Norwegian owners, Ocean Rig. But if they do find oil or gas and can extract it, It could be worth billions. Before Eric's maiden voyage, all systems are checked under the watchful eye of the captain from the bridge.
Testing has been going very well, actually. We've achieved almost more than what we expected to achieve.
Eric is already a well-traveled machine. The pontoons and legs were built in China. These were then towed to Mississippi, where the superstructure was added. Finally, Eric was hauled all the way here to Halifax Harbor for the final phase of fitting out. Control systems, beds, electronics, engines, ovens, lifeboats, propellers, and fridges. Once everything is complete, Eric will head for its first drilling location, the Torbrook Prospect.
Okay, we're going to move out through the harbor, through the buoy route, getting out into the lane system here, and this is where we're going to end up, in deep water. And this is where we're going to do the well, our first well. And this is about 120 nautical miles away from Halifax.
This trip will be no pleasure cruise. Eric is heading for a patch of sea best known for brewing the perfect storm, and everyone is concerned about safety. Eric is fitted with the latest escape equipment, including this prod-launched lifeboat system. Before Eric can leave harbor, every inch of the rig must be certified as seaworthy. Most offshore rigs are towed into position, but the Eric Roud can drive itself. Beneath each of the pontoons are 3 giant propellers, twice the height of a man, every one putting out 100 tons of thrust. But even when all 6 are running, Eric's top speed will be just 7 miles an hour. At last, the inspections are complete. Once the Eric Roud has been declared seaworthy, it can set sail.
So we'll be running 1 hour late according to our schedule. We hope to have the anchors weighed up by 3 o'clock this afternoon. And we'll be out there before dark and on our merry way to the oil field.
A ship can just sail over its anchor to release it from the sea floor. But for a monster rig like Eric, with 4 22-ton anchors stuck in the mud, it's not so simple.
Okay, keep her coming on full blast on the low speed.
Eric needs a tug to release each anchor from the sludge before it can wind the 3,000 feet of chain back on board. Each link is over 1.5 feet long and weighs over 350 pounds.
Yeah, 290 meter and 38 target.
Inch by inch, the anchors are hauled on board and sprayed with water to clear the corrosive, salty mud. It's a slow process. The tugs are only just strong enough to lift such heavy chains. It takes nearly 2 hours to lift each anchor, and the departure time gets later and later. Even as night falls, the last anchor is still stubbornly wedged in the Halifax sludge. The first step in the search for oil and gas is to pinpoint the most likely rock formations that could contain oil several miles underground. The creation of fossil fuels began millions of years ago, when rotting microorganisms were washed down channels of rock and sank to the bottom of the Proto-Atlantic Ocean. This organic debris formed great beds of sediment, and over the course of several million years, this sludge has been crushed and covered over by thousands of feet of rock, and has rotted and decayed into oil and gas. The only way to analyze rocks beneath the seabed is with a seismic survey. Shockwaves fired through the sea are reflected off layers of rock deep in the Earth's crust. Geologists can then decide if the right rock formations are present to keep refineries busy producing fuel for our cars, planes, homes, and power stations. At the Norwegian University of Science and Technology, researchers are working with a state-of-the-art 3D virtual reality suite to take them on a journey to the center of the Earth. They call it the Pterodec. The Pterodec takes data from the seismic survey and makes a three-dimensional map of the rock formation several miles below the surface.
It's much more natural for us to work in 3D because it's the natural environment.
Oil companies like Encana have poured millions of dollars into these 3D simulations to give them an instinctive visual impression of where the oil might be lurking beneath the bottom of the sea. Finally, under cover of darkness, with all four monster anchors freed from the mud, the world's most powerful and sophisticated drilling rig, the Eric Roud, fires up its massive thrusters, powers its way out of the safety of Halifax Harbor, and heads offshore to search for oil buried under the most treacherous seas on the planet.
Feel great. We're on our way now, you know, onto the field. Doing what we're supposed to do, drill holes in the ground, find some oil.
It will take 26 hours to travel the 133 miles to its first drilling location, but the world's most extreme oil rig will soon begin drilling for oil. Energy use is on the increase, and demand for oil and gas continues to grow. Insecurity of supply in the Middle East is pushing oil companies to explore inhospitable corners of the world, places that just a few years ago were thought impossible to reach. Our unquenchable thirst for oil has driven a massive surge in technology to help locate fossil fuels and to build rigs that can drill in the most extreme conditions. Finally, after 4 years of planning and construction and 26 hours of thrusting through the Atlantic, the Eric route has arrived at the Torbrook Prospect, a vicious patch of sea 133 miles off the coast of Nova Scotia, and has begun drilling its first exploratory well. There are potentially huge reserves of oil and gas under these waters, but until now, no one has dared to explore in this depth of water and in such bad weather. It takes 120 people to run the Eric route. 2 teams of 60 that work 12 hours on, 12 hours off for 3 weeks at a stretch. Then everyone gets 3 weeks back home while another crew keeps the drill turning. Eric never gets a break. It will keep drilling for oil 24 hours a day, 7 days a week, 365 days a year. Drilling for oil is expensive. It costs tens of millions of dollars to sink a single well, so careful planning is crucial. In the Teradek Virtual Reality Lab, geologists can explore a reservoir of oil and with a twist of a head, look for the best place to drill.
Okay, and move to it, see. Yeah, so there's a big fort over here, big.
The beauty of the Teradek, it really allows you to be almost inside the data, like you're in a 3-dimensional movie that allows you to visualize and understand how that oil was deposited and what it looks like miles below the ocean.
Oil doesn't just lie in a big underground pool. It's held in microscopic holes in sandstone, and gas is not sitting in a great bubble. It too is locked in the porous sandstone.
So the big challenge is to try to find the sandstone, because that contains oil. By using this virtual environment, it's much easier for us to find the 3-dimensional sand bodies.
The latest rigs, like the Eric route, are not restricted to drilling straight down. They can drill around corners and even horizontally. The aim is to hit as many oil reserves as possible using one well. In this image, the blue blobs are sandstone full of oil, and the red lines are wells.
You see that little blob over there? That's a sand body full of oil. Now, you see that well path misses that one. That was done prior to using an environment like the one we are standing in now. Now, the other one, however, was done after the engineers had been discussing, looked at this in a virtual reality environment, and then they were able to go through both of those bodies. If you turn it a little bit up, you see how nicely it goes into this body, and it goes into this main body here, and also it hits this sand body. And that proves the value of using such a tool.
The Encana geologists used this amazing technology to analyze the seismic data for the Torbrook Prospect and to choose the best spot for Eric to drill.
See that lower level. Okay. And what you'll see is that they track very nicely. What we believe is that this nice high amplitude.
The reason we're looking for hydrocarbons in places like this is that they are very large accumulations. 1 trillion cubic feet of gas or more will exist here. Now, 1 trillion cubic feet of gas, if we put it in context, would heat about 6 million homes for a year.
This is the first great challenge for the Eric route, to drill down 12,000 feet and tap into this great reservoir of gas. In any rig, the heart of the operation is the drill floor. Eric Roud is about to start drilling the first well in its hunt for oil and gas. The first hole to be dug will be a pilot well using this small 12-inch bit to check for dangerous gas leaks and to test the seismic rock data. The drill bit will be lowered down by length after length of drill pipe, but the first few sections, known as the bottom hole assembly, or BHA, contain electronic sensors and the drill bit motor. These sections have to be joined together carefully by hand, swung into place, screwed and tightened by the roughnecks. Once the BHA is assembled, in this latest generation of rig, most of the rest of the drilling process is automatic, controlled from the safety and comfort of the doghouse by the driller.
At the moment, we're now drilling the pilot hole, 12.25-inch pilot hole for the new well. Everything's looking good. No problem so far. Everything's new, so we're all learning.
The main drill pipe, or string, hangs from a giant crane known as the top drive. As the drill string is lowered through the drill floor, the next section of pipe is swung into place by the pipe racker. The new length of pipe is screwed into the existing string. Then, under the watchful eye of the real roughneck, the joints are tightened by the iron roughneck. This used to be the most dangerous part of the job, and many a roughneck lost his finger throwing the steel to tighten the joints.
This is very, very nice for everybody. Good for the roughnecks. It's not so hard on them anymore. The hard work has been taken away by the push buttons and the touch screens now. Getting cold, wet, dirty and nasty. No, don't miss it at all. This is good.
It will take Trevor and his team more than 24 hours to lower 66 sections of pipe to reach the seabed 6,000 feet below. Then, as the drill hits solid rock, Eric will perform one of its greatest tricks, holding position over an exact spot on the ocean floor. Three times a week, the Eric Roud has a crew change. Offshore workers, or salties, refer to the shore as the beach, and it's a 1.5-hour helicopter ride from the beach to the rig. It's time for a new captain, and Sandra Skifel is arriving to take over from Lars Johansson. The chopper only stops long enough to refuel, so there's not much time to swap notes.
With using our handover procedures and our email and internet and telephone today, the communication lines are open to the beach all the time, so you can speak before he arrives. We would like to get some more overlap into each position, but it's really not possible with this helicopter transport back and forward. And it's part of the work offshore to have a very short handover. Just a handshake, more or less, and that's it.
One of the captain's chief responsibilities is to make sure the rig doesn't move. Eric is designed to work in ultra-deep water, and there's no way it can be fixed to the bottom of the sea like a normal rig. Instead, it floats free, dangling its drill pipe down to the ocean floor. Whatever the weather, Eric must stay in exactly the same spot. It uses a system called dynamic positioning, or DP, to hold its place above the well. Eric monitors up to 6 global positioning satellites at a time to find out exactly where it is and where the sea is trying to push it. The DP system then sends a signal to each of the 6 thrusters, telling them how hard to push and in which direction to keep Eric glued to the spot. The system is so powerful, Eric can hold position within a few feet, even in 50-foot waves and 60-mile-an-hour winds.
She's so strongly built, and she's equipped with so much power, so much high-tech DP equipment and thrusters and generators that we are powered to run Halifax City with power if we want to do that. But when the wind picks up and the sea picks up, we will see her rolling and pitching a little bit more, and that is expected.
Much of the technology on the Eric route has been tested before, but never on this scale or in these conditions.
No, we are just blowing everything up to a higher scale, and we are doing the same thing in deeper water with more high-tech equipment, with a bigger derrick, with everything is blown up. And it's all turning around that drill in the middle here to go down and make a hole and find oil. That's the main goal, and everything around it is built for that reason, to do that hole in the ground.
It's not the roomiest elevator. We're going to go all the way down to the pontoon.
Sven Einarson is responsible for the machinery that keeps Eric upright and in position. Like an iceberg, Eric has more beneath the surface than above water. 78 feet beneath the sea at the bottom of the pontoons, Sven is sealed in with his machines by watertight doors. Eric is one of the most complex machines on the planet. It's 472 miles of cable and 113 miles of pipe are constantly humming, buzzing, and throbbing to keep the thrusters pushing and the drill turning.
Right behind me here now, we have the sea. If you go one story up, you'll have the sea. So we're surrounded by sea, and we're 24 meters below the surface right now.
Eric has 6 thrusters, 3 slung beneath each pontoon, each driven by its own gigantic electric motor.
We're now rotating at 5%. I would imagine that the output on this one now, the force we're actually thrusting would be around 4 tons. We're doing 38 revolutions a minute. Maximum revolution on the shaft here is 750 revolutions.
If all 6 thrusters were running at full power, Eric could produce 600 tons of thrust and would use 16,500 gallons of fuel a day. Eric may be searching for oil, but it's also the ultimate gas guzzler. At its top speed of 7 miles an hour, Eric does just over 100 gallons per mile.
Its equipment is getting so automated, and we are pushing it all the time deeper and bigger. So now we are trying out new pioneer projects like this. 5th generation built to drill in deep water. We didn't think this was possible just 10-15 years ago.
So far, conditions have been relatively calm, with waves only up to 15 feet and winds just 40 miles an hour, a mere force 9 gale. But there's a saying in Nova Scotia, if you don't like the weather, wait an hour.
No, I'm confident in that she will behave okay. And we will ride that, whatever storm comes by, we'll ride it off. I think so.
To help keep an eye on events a mile below deck, Eric has a small submarine, a remotely operated vehicle, or ROV.
Okay, how much go into the cage and Gonna turn around here.
We're gonna go back, roll pipes right ahead of us, right?
The ROV provides a live video feed to the control room and can monitor subsea operations down to 12,000 feet.
This whole drill rig and all the industry is built around these drill bits, because this is the thing that sees the oil first. This is once it sees the oil, then makes the oil companies happy, makes everybody happy, I guess.
Just like on the drill floor, automation here has made Doug's work a whole lot safer.
There's a lot of technology that's gone into all this stuff. ROVs have come a long way. They chase the diver out of the water, more or less, because divers can't survive at this depth. I started off diving 30 years ago on this coast, almost in the same areas here. But we were in maximum depth we were in, it was 400 feet, 120 meters. Now look at us, we're in 16, 17, 18, 2,000 meters of water. It's phenomenal. This ROV is just taking over the man.
As the drill bit punches the ocean floor for the first time, Eric celebrates the start of its first well. But no pop of champagne corks, not on an oil rig, just the clunk of metal on metal as the drilling continues. Work slows down now as the drill has to grind its way through layers of rock. It takes about an hour and a half to push down each 90-foot stand. The drill is like a giant domestic drill with a very long shaft. The top drive pushes down the drill string and rotates its entire length of up to 30,000 feet. But as well as that, the actual drill bit is further rotated by a fluid-driven motor at the bottom of the pipe. A special liquid called mud is pumped down the center of the drill pipe. When this mud hits the turbines of the drill bit motor, it spins the bit fast enough to crunch through the rock. Day and night, this is the daily grind for the offshore workers, the roughnecks, roustabouts, drillers, and tool pushers. It's dirty, noisy, cold, wet, and potentially extremely dangerous. The Eric route is fully winterized. It can keep drilling 98% of the time in winds up to 70 miles an hour, a violent storm, force 11 on the Beaufort scale, and in waves up to 60 feet high. But beyond that, drilling must stop. If things get really bad, the drill string must be pulled up so Eric can float away and ride out the storm. In an emergency, the pipe can be cut in less than 40 seconds. Conditions on the Eric route may be tough, but the pay is good. And everyone is committed to the task of drilling a large hole several miles into the bowels of the earth.
Whatever the weather is, it doesn't bother us for how we're on it. It just keeps going 24 hours a day. The only thing that will stop us is the height of the seas and the amount of heave that the actual rig is taking. Other than that, we'll just keep going 24 hours a day. Rain, snow, wind, ice, nothing stops. We've had waves, 70, 80 foot waves, actually breaking over the main deck. Containers getting thrown all over the deck. Waves just come up and hit, just spread, spray all over the place. Love rough weather.
America's drilling in the seas where the Titanic struck ice and where the perfect storm hit. It's designed to survive the worst kind of weather, a hurricane. Force 12 with winds over 80 miles an hour and waves up to 70 feet. This is called the 100-year storm, the worst conditions that could possibly be expected in 100 years.
We're speaking about these 100 years waves, and they do all kind of statistics to come up with waves, but we have to take everything. We don't have any options, do we? The weather who comes, we have to take it, if we want it or not.
If things do go wrong on a rig, then all hell can break loose. There have been disasters offshore, and there's nowhere to run. Piper Alpha, West Vanguard, Gorilla 1, Petrobras P-36. The names of stricken rigs still bring terror to any offshore worker's heart.
167 men died in an explosion on the platform.
Vanguard hit a pocket of gas, which was then ignited by a spark. The 80 crew couldn't shut the gas off.
36 hours after the blowout, oil still gushed out unchecked from the well. There was the added danger of
standing off at a distance, pumping thousands of gallons of seawater.
The work to stop the flow of oil and gas could take weeks. It would be many more.
A fire at an oil rig has finally been brought under control after burning for 9 days. All 69 rig workers were rescued, but damages put over
Piper Alpha will mean the grim search for bodies can begin.
From every disaster comes a massive drive for safety, and the Eric Roud safety systems are second to none. If there is a fire or an explosion, the crew needs to get away fast, and Eric has the latest design of sealed lifeboats that are flicked away by a giant prod.
It's designed so that it can run through gas, fire and oil. The boat becomes...
Everyone who works offshore must do 5 days safety training, preparing for the worst.
Basically, with a lifeboat, you can survive quite a while as long as you have fresh water, and the water and food supply in there is enough for 6 days. The odds of being in there that long when you're working in the oil industry would be very slim because you have your standby vessel there, everybody knows where you're at. So it's only a matter of waiting out the time, and in most cases, 24 hours to 36 hours, the sea state usually subsides enough to do a safe rescue.
Emergency, when the lifeboats are lowered, the prod gets pulled down like a giant fishing rod. The lifeboat is released when it hits the water, and the prod flicks it away from danger. One man who knows the value of lifeboats from first-hand experience is Clinton Carreau. In 1988, he survived 22 hours in a lifeboat after abandoning this rig, the Gorilla 1, off Nova Scotia. It was badly damaged by 60-foot waves and about to capsize.
I can't even describe how bad it was psychologically because you're going from the big rig to the little lifeboat. Nobody had ever done this before that I know of, and you're obviously afraid of the unknown. Am I going to live? You don't know. At one point in time, we were hit by a wave that completely buried the lifeboat, and I found out after the fact that the captain of the standby vessel actually went to make a note in his logbook that he thought that we were finished because he seen the wave break right over top of the lifeboat.
2 hours after the crew abandoned the rig, it capsized into the Atlantic. Clinton and the other survivors rode out the storm in their lifeboat before being rescued 22 hours later.
I have all the confidence in the world in these lifeboats. Saved my life, so what more can you say, right?
The only way offshore is by chopper, and one of the worst nightmares is failing to make the safety of the landing deck and ditching in the sea.
4500 Panama 64. Shamrock 105 Heavy, turn left landing at 270 to maintain 3000.
This ditched helicopter stayed upright just long enough for everyone to escape. But a floating chopper is extremely unstable. All the weight of the engines is at the top, and one hefty wave could flip the whole thing upside down in seconds.
Ditching, ditching, ditching.
During basic safety training, everyone must learn to escape from a ditched helicopter.
Most people are very afraid. It can be a very scary and unnerving thing to be put in a seatbelt, strapped in an enclosed space, and flipped upside down underwater.
In calm conditions, most adults can hold their breath for up to a minute. But in an emergency, with the shock of dark freezing water, no one can manage more than 10 seconds.
This time we're going to go back in, you're going to be in the same seats. First one's the worst one, the water up your nose this time, so it's going to happen again. Okay.
During training, you can practice several times over. But in the real thing, unless you get it right, your first ditch attempt will also be your last.
Adults have a tendency to retain information better if they actually do simulations or hands-on training, build a little muscle memory and be able to retain that a lot longer than sitting in a classroom listening to an instructor or just watching a video.
Safety divers ready? Ditching, ditching, ditching.
If you ended up in the ocean unprotected, your rate of survival goes way down. And water temperatures off the east coast of Canada here will go down below freezing.
In seawater that's 2 degrees below zero, without protection, you would die within 15 minutes. An oil rig worker depends on his survival suit. It would give him an extra hour before his core body temperature dropped beyond hope.
We want people to realize that this is training where you're doing something that hopefully you'll never have to use, but it's a chance to practice something that could save your life later on.
Back on board the Eric Roud, the pilot well is finished. No dangerous bubbles of gas were spotted, and plenty of data about the rock formations was gathered. But before they can drill the main hole, the drill team must change the drill bit. No easy task when it's over 2 miles beneath the sea. Changing the bit on a 12,000-foot drill is a complex operation. The whole drill string must be hauled up and dismantled, all 123 90-foot sections. The old 12-inch bit is taken off, and the new massive 42-inch bit is installed to begin the main hole. It will dig the top 600 feet of the well, after which a series of smaller bits will keep grinding through the earth. The whole assembly must now be lowered back down again into the depths of the sea. Pipe after pipe, night after night, shift after shift. could take up to 60 days to finish the well, before anyone finds out for sure if there's oil or gas in the Torbrook prospect. Working in these conditions takes a certain kind of person. You have to be tough to put up with the hard work, the noise, the dirt, the weather, the danger, and the isolation.
It's a very close-knit family. It's all a working team. Once you finish your 12-hour shift, you can actually go away and you'll have a shower, you go and have your meal, you get in your 8 hours sleep. So really, in your off time, you've maybe got 2-3 hours to actually do what you want. You'll watch a movie, and the rest of the time is just work, eat, sleep.
The rig may revolve around the drill floor, but the real center of operations is the smoking room.
Out here, and he is for danger that lurks everywhere. So hardy are we.
There's not much to do on an offshore rig. No drinking, no gambling. But you are allowed to sing and you are allowed to smoke in just one small room with no windows.
It's, of course, your time off home, but I don't miss much. I enjoy it out here. Times go fast out here. It's busy life. We are getting it in our blood. It's our life to work offshore. We're more or less addicted to work out here.
And H is for home, where we stay if we home. So hardy are we who work out on the rigs, where the seas they roar and the waves are so big.
They work hard, and when you have worked your 12 hours, you have your meals. It's not much time left. But I would say people wear themselves out just by working hard.
After this hole, Eric will move on and dig more exploratory wells. For the oil company in Canada, it will be a good strike rate if they find oil or gas in one well out of every 5. If they do find a strike worth exploiting, they must then design a custom-made production rig to extract the fuel. Our thirst for oil is so great, we'll brave the deepest seas, take on the worst of the weather, dig 5 miles through the earth in the hope of finding a sniff of oil or gas. No one yet has built a machine extreme enough to extract these hidden reserves, but the Eric route is the first great step in mining the most inaccessible oil on the planet.